Hello everyone! It's me again, Teacher Joanne. This tutorial is for statistics and probability, a subject which is intended for grade 11 senior high school students in the Philippines. Today's objectives: at the end of the lesson, the learners will be able to illustrate the t-distribution and identifies percentiles using the t-table. For today's topic, we have students' t-distribution. T-distribution. So what is a t-distribution? So it is a probability distribution that is used to estimate population parameters when the sample size is small, so which is less than 30, or when the population variance is unknown. So if the population standard deviation is not known, then it must be estimated using S, which is the standard deviation of the sample. So when S is used and the sample size is small, we use the t-distribution. It is also known as the student's t-distribution because when it was developed by William Seeley Gossett in 1908, he used the pen name student when he published his paper, which describes the distribution. When the t-distribution is used, remember the following. The samples must be simple random samples and are taken from normal or approximately normal distributions. So instead of using the standard normal statistic Z equals sample mean minus population mean divided by the standard deviation of the population over the square root of the sample size, which requires the population standard deviation. So we use the statistic T equals sample mean minus the population mean divided by the sample standard deviation over the square root of the sample size, in which the sample standard deviation S replaces the standard deviation of the population. The test statistic is also called t-test. In the t-distribution, the concept of the degrees of freedom, so denoted by df, is used. The degrees of freedom are the number of values that are free to vary after a sample statistic has been computed. For example, if n equals 5, so df equals n minus 1 equals to 4, meaning 4 values are free to vary and 1 must be a fixed value. The shape of the t-distribution depends on the degrees of freedom. So the smaller the degrees of freedom, the flatter the shape of the distribution, and as it increases, it gets closer to the standard normal distribution. So as you notice from the graph, so we have the one colored blue, red, and then we have the green. So for the blue one, it's the standard normal distribution. Then we have the t-distribution that is close to 30, which is the red one, and t-distribution smaller than 30, which is denoted by the green one. So as you can see, as the sample size decreases, so it looks flatter. That's why the green one is the flattest of the three graphs. So we have the t-distribution versus the normal distribution. So how exactly are they different? So from this table, we have t-distribution on the left side and the normal distribution on the right side. So for t-distribution, it is more spread. Unlike normal distribution, it is less spread. So in terms of the tail, there are more areas on the tail on the t-distribution compared to the normal distribution. And in the area in the center, so there are less area in the center for t-distribution and more area in the center for a normal distribution. So t-distribution is used for smaller sample size, so which is less than 30. And for large sample size, we use the normal distribution. And for the population standard deviation, it is unknown for t-distribution, and for normal distribution, it is known. So now let us discuss the properties of t-distribution. So for the first property, the t-distribution has a mean equal to 0 and is symmetrical about the mean. So you can see from the illustration, so we have the mean equals to 0 and it's symmetrical about the mean. So next property we have the t-distribution is bell-shaped like the normal distribution but has heavier tails. So from the graph, you can see the red one is the standard normal distribution and the t-distribution is the blue one. And if you compare the tails, so from the blue graph up to the line, horizontal line, it's thicker compared to the red one, which is the standard normal distribution. So each corresponding curve is bell-shaped and also symmetrical about 0. So that's the property of both t-distribution and normal distribution. Then next, we have the mean, median, and mode are all equal to 0. So if you remember the property of the normal distribution, the mean, median, and mode are also equal to 0. So they are the same for this aspect. So the variance is always greater than 1. So it is equal to degrees of freedom divided by the degrees of freedom minus 2. So as the number of degrees of freedom increases and approaches infinity, the variance approaches 1. So as the degrees of freedom increases, the t-distribution curve looks more and more like the normal distribution as I mentioned earlier. So from the graph, you can see the difference between the graphs of the degrees of freedom equals to 1, which is the red one, and the blue one is degrees of freedom equals to 2, and then the green one, degrees of freedom equals to 5, yellow is degrees of freedom equals to 10, and the black one is the normal distribution. So the farthest from the normal distribution and has the thickest tail is the one with the degrees of freedom of 1. And the one almost closest to the normal distribution is the yellow, which have the highest degrees of freedom from the given. So the standard deviation varies with the sample size and is always greater than 1. So the total area under the t-distribution curve is 1 or 100%. So same thing with the normal distribution. The total area under the curve is 1 or 100%. So lastly, we have the shape of the t-distribution depends on the degrees of freedom. So we have this graph. So with a given area of 0.10 on the right tail of the distribution and a degrees of freedom of 20, so the t-value is 1.325. Then we have, so with the same area of 0.10 on the right tail of the distribution, but with the degrees of freedom equals to, the t-value is 1.886. So if you notice, the t-value is different even though the given area is the same. That is because of the difference in the degrees of freedom. So from the first graph or the graph on the left, so it is closer to the standard normal distribution because of the degrees of freedom. And for the graph on the right side, so it is flatter and farther to the standard normal distribution. So the difference is with the degrees of freedom of the two graphs. And also, if you notice, for on the graph on the right side, the tail is thicker compared to the graph on the left side, because as the degrees of freedom decreases, the tail also becomes thicker. Now let's check what have we learned. So write true if the statement is correct and false if otherwise. Number 1. T-distribution is a probability distribution that is used to estimate population parameters when the sample size is small or when the population variance is unknown. Number 2. The shape of the t-distribution depends on the degrees of freedom. Number 3. The smaller the degrees of freedom, the flatter the shape of the distribution, and as it increases, it gets farther to the standard normal distribution. Number 4, the t-distribution has a mean equal to 0 and is symmetrical about the mean. And number 5, the standard deviation varies with sample size and is always less than 1. Okay, so now let us check the answers. Number 1 is true. Number 2 is true. Number 3 is false. Number 4 is true. And number 5 is false. So I hope you get all the correct answers, and that's a great job. So we're done for today, and thank you very much. I hope you learned a lot, and see you in our next lesson. Bye!